All right, so we're going to talk about laws of logarithms in this section 4.4. And this is just kind of a couple of three rules, I guess, that you need to learn, memorize, and be able to use. And then that's really all there is to this section. It's using those three rules. So let's see what they are first. So lowercase a is any positive number not equal to 1. That's going to be our base. And capital A, B, and C are any real numbers where A and B are greater than 0. And actually, I think we'll not even worry about the A there. So first we have log of A times B equals log of A plus log of B. So when we have product in here, we can split it up with addition and have a log on each one. And I'm not writing, it doesn't matter what the base is. So we could write A, but it doesn't matter what it is. So we could leave it blank, leave it as 10. ln would work, or whatever base we have. The next one, you might be able to figure this one out if based on the first one. If we have A divided by B, that is going to be separated by subtraction. And then the last one, if we have an exponent, log of, let's see, A to the C, we can kind of, this one's kind of using this one over and over again. So if we have A to the C, that would be A times A times A times A, C times, we can split that up. And actually, we'll kind of write this one out. So A times A dot 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 times A, so that would be C terms. Split those up using property 1 here, because we can use this. If we had A, B, C, we could do log of A plus log of B plus log of C. So you can do this one as many times as you have terms. And then how many do we have here? So we're adding log of A C times, so that would just be C times log of A. So essentially what you can do is you can bring this C or exponent down in front as a coefficient based on this first property there. So let's look at a couple of examples, and we'll work these both ways. So going this way and going that way. So you'll need to be able to do them both. So evaluate each expression. So we have log base 4 plus log base 4 of 2 plus log base 4 of 32. So we can use property 1, and 2 times 32 is 64. And now evaluate this based on how we learned to do this in the last section. So 4 to what exponent would equal 64. So this is a refresher. We can rearrange that to an exponential form. And so 4 to what exponent would equal 64? And so that will be 3. And so if you put that in the calculator, you would just get 3. All right, so B log, so we have log base 2 of 80 minus log base 2 of 5. So 80 divided by 5, which is log base 2 of 16. So 2 to the what exponent would equal 16? That would be 4. Then C, we're going to use property 3, so we'll bring the negative 1/3 up as an exponent. And so you could think of this, so sometimes the negative exponents kind of get a little bit tricky. And so actually, I think probably need to do this one in the calculator. So let's do log of 8 and then divided by negative 3, and we get negative 0.30103. Or I guess you could write this as log of 1/2. then we could do log of 1 minus log of 2. Log of 1 is 0, always. So this is just negative log of 2. So I'm not sure how the homework would want this. I mean, it would tell you to either, if it says round somewhere, then it's asking for this. If it doesn't say to round, it's asking for this. So either way. But that's generally just for any of these homework problems in anything. If you get a long decimal and there's nowhere to round, then you probably need to write it in a simplified form some way. All right, so use the laws of logarithms to expand. And so in this, we're not really getting an answer. We're just going to write this out like that. So we're just using that first property and expanding. And like this one we can take 2 steps to do. So now we've expanded it using property 1, and then we're going to bring the exponent down using property 3. All right, and then this one, now you can break this up into multiple steps, I guess. You could write this as ln of AB minus ln of cube root of C. And then we can expand this one. And then this is C to the 1/3, so bring the 1/3 in front like that. But you could really probably do this in one step. Any of the variables on top are going to have a plus in front of them. Any of the variables on bottom are going to have a minus. So you kind of skip this step. It's not necessary, but it doesn't add too much time either. All right, so combine. So let's first you want to get rid of your coefficients. So let's bring the coefficient up as an exponent. And we'll just write this one as a square root. And then we have the addition, so we can combine these with multiplication. So we have x cubed square root of x plus 1. That's the answer. All right, so when you're combining, that's the general idea that you want to use. So any of the coefficients you're going to put up as exponents and then combine to multiplication if it's plus, combine to division if it's a minus, or kind of the way I said it here or on the last page, anything with plus in front is going to be on the numerator, minus in front will be in the denominator. So move the coefficients up to the exponent. Ln of s cubed plus ln of square root t, and then minus ln of t squared plus 1 to the 4th. Now this one you could make it plus and then to the negative 4th. It doesn't matter because if it's negative 4th, that's 1 over t squared plus 1 to the 4th. And so you end up with the same thing. I usually keep the negative in front, and then that tells you this goes in the denominator anyway. But it doesn't matter. So now combine these two by multiplication. Those will be in the numerator. And then the t squared plus 1 to the 4th is in the denominator. So ones like these, probably you want to not try to do too much at once. Maybe once you have done this a little while and practiced some, you could kind of combine these steps. But when you're first doing this, try not to do too much at once. Try to just go step by step. And the last thing, change of base formula. So I think I mentioned this in the last section. When you're evaluating logarithms on a calculator, they only work most of them, and the only ones I've seen that this would be the exception is graphing calculators, which you're not allowed to use on tests. Um, they only work with the base 10, or you can use ln, which would be base e. So you cannot just work with any base. And so we need this change of base formula, which is here. Now we'll do these examples and you'll see how it works. So you could do, so log base 8 of 5, we can just make that log of 5 divided by log of 8. And that's it. You could pick any one. You could also do ln of 5 over ln of 8. You get the same thing. So either way, you get the same answer. So log of 5 divided by log of 8. You get 0.773976. If you do ln of 5 divided by ln of 8, you get the same thing. So either way works. Doesn't matter which one. So if we want to do this one, we can just do log of 20 divided by log of 9. And then you should get 1.36317. Okay, so just a very simple thing. Just because calculators, most of them, you can't just write or calculate a log in any base without this formula. So we have a couple problems like that on the homework, but other than that, just make sure you have memorized those first 3 laws, and then that's it. So this is a pretty simple section.